Good morning, it's Engineer Haider there, trainer and director of Next and Technology. I warmly welcome all of you guys on my channel. Today we are going to start our session on control system. We will learn two subjects in our this control system series: linear control system, which is an LCS subject, and the second one is a digital control system (DCS). So before starting off my lecture, I request all of you guys to subscribe and share this channel with student friends and family. I will also share my contact with you guys. If any one of you have an issue, she may ask me regarding the lecture of control system. So today we are going to learn about the system and control system. We will learn about two types of control system. So this one is our lecture number 1, introduction to systems and functions. It's me, Engineer Haider there. This is the Institute Next in Technology, Virtual Academy of Science and Technology. Here is my contact number. You can also contact me when you are facing any kind of issue in your lecture. So this one is our. So before starting of our lecture, the first topic we are going to study is the system. What is system? So after the system we will learn about the control system. So system, I just write the simple definition of a system. System is in simple word are some devices or a group of devices that take input and produce output. Mean we give input to the system. This one is our system. It take input mean let's say we are giving 2 to the system, and this one is the output, and it give us 4 in result. And now we are going to give 3 to the system, and in result it give us the 9. So the system in simple word are the some devices that generate output on our given system. 2 output is 4, 3 output is 9. So the system is a square system. Mean any number I am giving to that system as an input, it give me in a result the square of that number. So we have a square function or system here. So system is just like a mathematical function. Just remember the mathematical function. What mathematical function is basically have mathematical function which is denoted. Let me explain. Mathematical function which have f of x is denoted by f of x is equal to, let's say, y. Mean the value of the y depend upon this x. So the value of that y depend upon the value of x. Okay, so this one is known as dependent variable. We will deal with the systems and functions in our this subject, so it is necessary to learn about the function, that what are the mathematical functions and how to deal with the dependent and independent variables. So this one is the dependent variable. Why it's a dependent variable? Because we will get y as an output, because y is an output, and we will get the result of that y value which is depend upon that value of x. So this x is known as independent variable. Independent variable. So the value of x does not depend upon anything. So for example, we have this type of function here, which is function. Here we have input, which is x, and here we have output, which is y. Let's say I'm giving 3 to the system, which are a function, and in result I'm getting 4, and I'm going to give 4 to the system or function, and I'm getting 5. So what will be the output equation of that function? So it is f of x plus 1 equals to y. Mean addition of 1 in all the numbers is the value of the y. So 3 plus 1 equals to 4, and 4 plus 1 equals to 5. So we have that function x plus 1. So the value of y depend upon that function and on that independent variable. So 3, 4 are value of the x. Okay, now come back to the lecture. the system is just like same as the mathematical function. We have the functions in mathematics, in which we have already discussed what is the function and what is output and input and what are dependent and independent variable. It's just like same as a mathematical function. Let's say it's a mathematical function which is a system. This one is input, which is an independent variable, and this one is output, which is a dependent variable, and this output depend upon that input. This value is always depend upon that value. Just like same I discussed in previous slide, that if we are giving 3 to the system and it's give us the 4, that means this is x plus 1 function or x plus 1 system. So system is just like same as a mathematical function. But in control system or in control engineering, there are many number of systems are interconnected together to give us a desired output. So we will discuss in our coming lectures at what are in. Okay, so this one is the first type of system, which is a simple system. We will discuss in our coming slide that this first one is known as the open loop system. Open loop system means a straightforward system. The second one is I will explain open loop later. The second one is a closed loop system. I will also discuss this one in our coming slides. This one is a closed loop system. You can see that there is an input system and same just like the above. Is same like, but there is an another module or device which is a feedback. So what feedback is really about? So let's say, for example, you are running an air conditioner in your room, and you set the temperature at 25 degree. So the feedback is constantly checking the room temperature and making the comparison of that room temperature with the desired output. So when the room temperature reaches at 25 degree, the air conditioner automatically. So feedback is simply a comparison maker. You can just say that the feedback is a comparison maker, just like an example of an air conditioner. When air conditioner is running into your room and you set the temperature at 25 degree, and then that feedback is making the comparison between the output and input, and whenever the temperature reaches 25 degree, the air conditioner automatically cut off. So this is a feedback function. A feedback is simply a comparison maker between what input and output. So this one is known as a closed loop system. I will discuss the advantages and disadvantages of closed loop system now in our coming slide. So there are two types of system. We have open loop system and a closed loop system. So since again, system in a simple word are devices, are a group of devices that take input and produce output, which is a desired output which we require. Now you can see here the first diagram which I have told you in my last slide, that what the first one, which is a open loop system. Open loop system is here. Open loop system is a system in which the control action is totally independent of output system. Mean there is no comparison maker, there is no feedback function, and there is no feedback block there. So this is a straightforward system. You are giving input to the system and you are getting output of your system. So open loop system is just a simple type of system in which the output totally depend upon the input, and there is no comparison maker and there is no feedback in that system, which is an open loop system. Just like the previous one, let me show you this one. The first one is just an open loop system in which the input and output, you are giving input to the system and you are getting output of that system. So this one is simply an open loop control system. You can see the block diagram of an open loop system here, which is a straightforward block diagram. There is no, you can see that there is no comparison between the input and output. There is no feedback function in an open loop system. You are just, the first step is the desired process response, and you are giving that input to the controller of your system, and then the controller will give the output to the process, which is a processor or processing. So after this processing of that controller output, you will get your output of your desired system. There is no comparison feedback in an open loop system. So this is known as the open loop system. There open loop system in which control action is totally independent of the output of a system. Mean the action of your controller does not depend upon, is totally independent. Mean you are just giving input out to the system and you are getting output to the system. You are not getting Okay, here are some examples of open loop control system. The first one is electric hand driver. Electric hand driver. Second one is an automatic washing machine and the bread toaster maker and the tea and coffee maker. These are just the simplest example of the open loop control system. These are all example in which you are just giving an electrical signal or an input to the system, and you will get the output response of your system. There is no comparison or a feedback in your system. For example, in a washing machine, you are just giving an electrical signal to the washing machine, which is an input to that washing machine, in which washing machine is a system, and you are giving electrical signal to that system, and on that electrical signal you are getting the output. What desired output you want? You just want to wash your clothes. That's it. So open loop system are those system in which the value of the output always depend upon the value of input, and without any feedback on comparison between the input and output. So these are the basic and the main example, the simplest type of example on open loop control system you have. Now come to the advantages of open loop control system. In open loop control, the first advantage is simple in construction and design. It's a straightforward diagram or block diagrams. You can see in the block diagram that it's a straightforward and simple in design. That you have just required three steps to complete your open loop control system. The first one is output to the system, and the second one is a system, and the third one is output. Just like automatic washing machine, you have just three steps. The first one is giving an electrical signal to the system. The system is our washing machine, and the output is washing of the clothes. So open loop system is simple in construction and design. Economical mean low cost, not much expensive. You just need a little cost to design your open loop control system. Easy to maintain mean there is no complexity in your open loop control system. There are no interconnected system, no advanced level connected system. It's just a simple. So easy to maintain mean that you can easily do maintenance of your system, which is not a complex system and not a difficult system to understand. You can just easily make the maintenance of your open loop system. So what are the disadvantages of open loop system? The first one is inaccurate. There is no accuracy. Why the open loop system is inaccurate? Because there is no comparison or a feedback in an open loop system. So the value of the output may be accurate, or when there is an inaccuracy in the output, any change in the output cannot be corrected automatically. So it means that there is no comparison maker between the input and output. If there is any change in the output, so the output is not corrected automatically, just like we have in a closed loop control system. So these are the two disadvantages of open loop control system. So whenever you are going to ask about what is open loop control system, you always have to define what is open loop control system, draw the block diagram. So whenever you are ask about what is open loop control system, always say that open loop control system is a system in which the action is totally independent of the output of the system, and draw this block diagram without a feedback or a comparison maker. You have just a desired process giving to the controller output process, and the process output you have. And always write one or two example for your system and advantage and disadvantage of the system. So open loop control system is complete. Now come to the next one, which is a closed loop control system. Now you can see the control system, which is a closed loop control system. You can see the same block diagram. Just like an open loop control system, the new thing is there is a feedback or a comparison maker between the output and the input. The one thing you have to remember is that the closed loop control system is also known as automatic control system. Why automatic control system? Because when there is a slightly change in the desired output of that system, it will change automatically, adjust the desired output of a system by using the input of that system, by making the comparison by using the feedback element between the output and the input of that system. A control system is an automatic control system, a system that is closed loop and feedback is there that makes suitable change in the output due to the external disturbance. The external disturbance on a system, let's say you have an interconnected system there in an industry, and the disturbance on that machinery or on that system is a temperature, pressure, air, humidity. What are external disturbances on our system? Let's say we have an interconnected system on our power plant or industries, and this is a complex closed loop interconnected system together. And what are the external disturbances on that system? External disturbances on a system make change in that desired output. So So external disturbances are disturbance is temperature effect on that system, pressure effect on that system, humidity effect on that system, air pressure, mean any outside disturbance on that system is an external disturbance on that system, and that external disturbance make a slightly difference in our output. So feedback, which is a comparison maker between the output and the input of that system, is always give us accuracy is a most important factor in our closed loop control system. The first one, in an open loop system, we have discussed that the open loop system are inaccurate because there is no accuracy. So we have learned that there is no accuracy element present in that open loop control system. So in a closed loop system, there is an accuracy element present in a closed loop control system. So that accuracy element give us the accurate output of our desired input. So all the external disturbances which affect the change in the output of our system is always give us the accurate response or close to the accuracy of, let's say we need a value of 3.66, and due to some external disturbances we get the value 3.42. So feedback element, this feedback just make the comparison between the output and input. For example, let me give you an example on that to learn what is control system, what control closed loop control system is really about. So let me give you a real life example on that feedback, that how this feedback element work. For example, everyone is using an air conditioner in the houses, and this air conditioner you are giving, let's say, out input by using the remote control, and you set the input as a 25 degree, and you want the room temperature to be set at the 25 degree Celsius, and you run the AC, and when the AC is running it, the output is all there is a temperature sensor in that air conditioner that is sensing the temperature of that room with the desired input. The desired input is a 25 degree, let's say 25 degrees our desired input. And so in the output there is always a temperature sensing means the temperature is constantly sensing the room's temperature, that whenever the room temperature reaches the 25 degree, the feedback gives instruction that the room temperature is reached at 25 degree, then that air conditioner automatically cut off. So when the temperature reaches 25 degree, the air conditioner will stop. So we will learn and discuss the closed loop control system detailedly with complex systems later in our coming lectures. So let's come to the next point, which is are the examples of the closed loop control. First one is a water level controller. Water level indicators are based on the closed loop control system. You all are familiar with the water tanks you have in your houses, that there is a water level indicator in that tank. Whenever the water level reach below that point, the pump or water pump automatically turn on. So water level controller use three type of instruction: the high, middle, and the lower. Whenever the water level reaches the high point, the water supplying to that tank is cut off. So water level controller depend upon the closed loop control system. Air conditioner, I just covered the example of air conditioner, how air conditioner work. The third one is a cooling system in a car, is just like an air conditioner. In our coming lectures, our control, this subject, control system and control engineering, is a totally mathematical modeling and mathematical based subject. So this first lecture is just a theoretical subjects in which we have to cover the definition first. After all the definitions covering all the definition, we will move forward to the mathematical modeling of that system, and we will start from the basic systems and functions. The mathematical function, we will start from the mathematical function, what are mathematical functions and how to deal with the mathematical function. And after this we will start the open loop systems, and then we will move forward to the closed loop system. We also learn about the response, which is a unit step response, and what are LTI systems. Each and everything we will cover in linear control system. And in digital control system, we will learn and cover the advanced level topics. So come to the advantages. The first one is a more accurate. Why more accurate? Because there is an accuracy present in that closed loop control system, which is a feedback.